Right, hello grade 9s and welcome to the next section. We've just finished Algebra 1 and so now we're starting Algebra 2. And the whole point of Algebra 2 is factorizing. So there's going to be a couple of topics, but topic number 1 is all about factorizing. Now factorizing is probably the most important skill you'll learn in the whole of grade 9. We use factorizing in pretty much every section we ever do in maths. It's a huge influence on other sections, and so it's really important that you understand it. So in the lessons we're going to go over lots and lots of examples so that you get more and more comfortable. It's also unlike anything you've done before, so please make sure that when you hit parts of the homework that you look at the memo and you don't understand, send a message and I can talk you through it. Okay, so first of all, what is factorizing? Factorizing is basically when you rewrite something, an expression or a number, as a product of its factors. So when you rewrite an expression, now this is probably going to mean nothing until we do examples. So rewrite an expression as a product of its factors. Now really importantly, I've typed out these notes so that it helps me with your lessons, but most importantly, please, whatever I write on the page, whatever's typed on the page, these notes have to be in your book. So literally I want you to write like we would be in class: Algebra 2 heading, subheading, topic 1 factorizing. What is factorizing? Factorizing is when we rewrite an expression as a product of, I should say, its factors. So please make sure that you have all of these notes down with the little notes that we write in, with all of the examples, exactly like we would have done in class. Okay, so that kind of means nothing to us right now. So let's look at a silly example. So for example, if you have the number 6. Now, this is really quite a silly example, but how could you rewrite 6 as a product? Now, what does the word product mean? Product means multiply. So how do I rewrite 6 as a product of its factors? Well, what numbers go into 6? I could rewrite 6 as 2 times 3. So I have rewritten 6 as a product of its factors. Now that's just a bit of a silly example because that doesn't really get us anywhere. So very soon you'll see how this is different and important. Now the most important thing is the aim of factorizing is to take many terms and to make it one term. So we're going to see loads of different reasons why factorizing is really important when we start using factorizing. But the main aim of factorizing is to take many terms and rewrite it as one term. Many terms and rewrite it as one term. So, unfortunately, for the first, good week or two, we're basically just going to be learning what factorizing is and the different types of factorizing. So at the moment it's going to seem like, yay, we're learning the skill, but why? And then eventually when we start going, okay, so where do we use this? By the time you finish grade 9, you're going to go, oh, that's really useful. By the time you finish matric, you're going to realize that factorizing makes up like 40 marks of your matric paper. It's that important. So factorizing is taking an algebraic expression and rewriting it as a product of its factors, and your aim is to always take many terms and to rewrite it as one term, because anything that's a product would be one term. Okay, now in grade 9, we're going to look at 3 different types of factorizing. So I've called them 1.1, 1.2, and 1.3. And each time we do a factorizing, we'll do easy examples, and then we'll practice, and then we'll do some more difficult examples. But largely, there's 3 types of factorizing. Our first types of factorizing we refer to as the HCF. Now, you will know what HCF stands for because we've kind of done this type of idea before. HCF stands for highest common factor. This is always the first type of factorizing you must check for in any single factorizing question. The first thing you do is you check for a highest common factor. Okay, now what does this mean? Well, example 1 is what we've done in Algebra 1. What we spent the whole of Algebra 1 doing was multiplying out. So if I look at example 1, it says simplify, and this is just distribution. So 5 times a, which is 5a, and then 5 times 6, which is 30. So that's the whole of Algebra 1, is multiplying out products. Now you'll notice in this answer here, there are now 2 terms. So this has 2 terms. If you look at the question, you'll notice the question has one term. Okay, so Algebra 1 was all about simplifying, so taking the question and multiplying out, and we call that simplifying. Now, what factorizing is factorizing is the exact opposite. If I give you this answer, can you go back to writing it as a product? So this is what factorizing is. It's almost unsimplifying in a way. You're taking the answer and you're rewriting it as the question. Now again, you might say, why? I've just learned to multiply it out and now you must tell me I must undo it. I promise you factorizing, just bear with me, factorizing is going to be hugely powerful and useful. So notice the answer is 2 terms, but if I would factorize it back to the question is actually 1 term, and it's a product. It's a product of 5 and a plus 6. So let's look at our first example of actual factorizing. Example 2 says factorize, and it's given you 5a plus 30. Now that is 2 terms, and you'll notice that that's exactly the answer to example 1. So what do we mean when we say factorize? Well, the first question we ask ourselves is if this is 2 terms, we say to ourselves, is there a number and a letter? Because letters could also be highest common factors. Is there a number or letter that is common to both terms? So if you have a look at this particular question is 5a plus 30. So is there a number that goes into 5a and into 30? And my answer in this particular question is yes. 5 goes into 5a and into 30. And so what we do is we call it factorizing out. So we say we're going to factorize out the 5. So I'm almost taking it out of the distribution. So I'm factorizing out the 5. Now I put a bracket. And then I say to myself, so I'm almost undoing products. If you understand products, you understand factorizing so much better. Then I say to myself, what must I multiply 5 by? What must I multiply 5 by to get? Now what is the first term that you want to get out when you do the product? I want to get 5a. So what must be in the bracket so that when I multiply out, I get 5a? Well, clearly there must be an a, because 5 times a would give me 5a. Then I say to myself, now there should be another term, and I say, what must I multiply 5 by to get to 30? Because that's the other term that should be produced when I multiply this out. Now 5 times what will give me positive 30? It must be positive 6. And you'll notice that's exactly what the question was. So I deliberately chose that answer to try and show you how we think about the reverse, which is factorizing. Now I hope all those notes are written down. And anything that I say that I don't write down but you find useful, do write it down. I'm going to try and write down as many notes as possible. Okay, so let's try the next one. This whole exercise is just about highest common factors. So we say to ourselves, there are 2 terms here. So, is there a number or a letter or both that goes into 3a and 15? Or letter that goes into 3a and 15. Now there's no letter that goes into both because 15 doesn't have a letter, but the answer is 3 goes into both. And now we say to ourselves, right, what must I multiply 3 by? So 3 times what is going to give me 3a? Because when I multiply out, I need to get 3a. So there must be an a. So it's almost like what is missing. And then I say to myself, what must I multiply 3 by? If I'm meant to get positive 15 out, I must multiply it by positive 5. Now the wonderful thing about factorizing is you can always know if you're right or wrong because you simply multiply out in your head. So I say to myself, 3 times a would be 3a, 3 times 5, 15. Yes, I know I've gotten it right. Okay, so if you can do these two, you can do all of them. They're all the same thing. So let's look at the next question. Is there something common between a, b, and a? So what is common between AB and A. Now, there are no numbers, so no numbers can be common, but I can clearly see that A, B, and A both have the letter A in them. Now I say to myself, what must I multiply? So A times what is going to give me AB? This is going to have to be a B. And then I say to myself, A times what is going to give me A. Now, most people here will say nothing. They'll say, oh, you don't have to worry about it. You don't have to multiply it by anything. Now, if you don't have to multiply it by anything, how are you going to get it back out? So if you say, oh, no, nothing, then that's 0. And A times 0 would be 0. So there must be something there. So A times what will get A out? And the answer is A times 1. Now, very importantly, you must have that 1. Because otherwise, if you don't have that 1, if you just have A and then brackets B and you say, oh, I don't need anything else, then that's just AB. Where's the plus A? So you have to have the plus 1 so that you go AB, oh, A times 1 is A. Otherwise, if you miss out the 1, you miss out that A entirely. So that's not an invisible 1 that you can afford to leave out. Okay, so that's a really important thing. Most people struggle with that idea of the 1. Okay, onward. Now I'm going to stop writing so many notes. I'm going to talk through them. So I said to myself, there's 2 terms. What number goes into 6a and into 12? 6 goes into both of them. Letters, there's definitely no common letters because 12 doesn't have any letters. Then I said to myself, what must I multiply 6 by to get 6a? So that's A. What must I multiply 6 by to get 12? 6 times 2. Now multiply that out in my head, just so I know if I'm right or wrong. 6 times A is 6a, plus 6 times 2 is 12. So you always know if you're right or wrong. Right, on to the next one. Now this is quite an interesting one, because if I look at negative 2a and negative 10, what is common? Well, it's clearly a 2. So do you take out a positive 2 or a negative 2 as the highest common factor? Do you take out a positive 2 or a negative 2 as a highest common factor? Now the answer is it doesn't matter. It really doesn't. So there's actually 2 answers to this question. If you took out negative 2, now you just have to be careful about your signs. So negative 2 times what will give me negative 2a? Negative 2 times a. Then negative 2 times what will give me negative 10? Well, this would have to be positive 5, because a negative times a positive would give me a negative. So that's negative 10. Now, you didn't have to do it like that. So, or you could have taken out a 2, and then you would have said 2 times what gives me negative 2a. So that would have to be negative a. And then 2 times what gives me negative 10. That would have to be negative 5. So you'll notice that the sign is opposite outside the bracket, and then all the signs in the bracket are also opposite. So there's nothing wrong with taking out a 2 or a minus 2. But I always take out a negative if the first term is a negative. Simply because when we do our second and third type of factorizing, it makes that type of factorizing much, much easier. So I'm just going to write down a hint here, and then when we get to that, I'm going to say, do you remember me saying? So hint, if the first term is negative, it helps to take out a negative. I don't have to, but it's definitely helpful. So either of those answers are acceptable, and in the classwork that I'm going to give you, there's lots of questions where I've put 2 different possible solutions, depending on whether you decided to take out a positive or a negative, because it really doesn't matter which one until we get to our second and third factorizing, but we'll cross that bridge when we get there. Okay, on to some more practicing. Right, let's look at this one. This question says 2a squared b plus 4ab. Now remember, you must take out all the common factors, not just some of them. So lots of people will go, oh look, 2 is common. And then they'll go, great, so this is a squared b plus 2ab. Now that would be marked incorrect simply because you didn't take out all the common factors. Yes, 2 is common, but look, there's A's and B's there, and there's A's and B's there. And so when we take out a highest common factor, we always take out all the common factors. So don't just take out some of them. So always take out all the common factors as much as you can. That's why it's called a highest common factor. So if I have a look here, yes, 2 is common. Now, how many A's are common? Well, this has A squared, and this only has A. So once I've taken out an A, then that's gone. Then that term has no more A's. So there's only 1 that I can take out from both. Then if I look at the B's there are, well, there is 1 B there and 1 B there. So I can only take out 1 because then both of them will be missing from those terms left behind. So let's have a look. What must I multiply 2AB by to get 2A squared B? Well, the 2 is fine. I need an A because I need A squared. And the B is fine, it's already there. So that's simply A. Then I say to myself, what must I multiply 2AB by to get 4? Well, that must be positive 2. And then to get AB, well, I've already got AB. And so that's my factorizing. Now you'll be able to tell whether you factorized it properly because A, you can multiply out and check, but B, do you see anything common left in that bracket? Do both terms have an A or do both terms have a 2? And the answer is no. There are no common factors left, and so I know I've done my best. Okay, let's try another one. Oh, this has 3 terms. Well, that's not a problem. I just got to say to myself, is there something common in all 3 terms? Now, the letter A isn't common with the 9, so it's only the number 3. And so I say to myself, what must I multiply 3 by to get 3A squared? A squared. What must I multiply 3 by to get 6A? So that'll be plus 2A. So that'll be 3 times 2 is 6A. And then 3 times what will give me 9? 3 times 3. Right. Moving along nicely. On to the next one. Right. Again, 3 terms and lots of ABs. So let's just do this one a little bit more slowly. Let's look at the numbers first. This number's 4, 2, and an invisible 1, which means there's no common factors for the numbers because 4, 2, and 1, the only highest common factor is 1, which is pointless. Okay, let's have a look at our A's. Here we have A squared, A, and A, which means that only A is common because once I take out that A, this first term will have leftover A's still, but that A will be gone and that A will be gone. And so there's no other common A's left behind. Now let's look at our B's. I have B, B squared, and B. So I also think that B is common because yes, here there'll be leftover B's, but that B and that third term B will be gone, and so there'll be no B's left. So I think this is going to be fine. Now let's check. What must I multiply AB by to get 4? Well, 4. A squared, we'll need an A. B, well, I've already got a B, so that's perfect. What must I multiply AB by to get 2? So that's positive 2. A I've got. B squared, so I'll need another B. What must I multiply AB by to get 1 AB back? Well, I can't multiply by nothing because then I won't get it back. Now nothing's missing, so AB times 1 will give me AB. So notice if there's 3 terms in the question, when you take out a highest common factor, you have to have 3 terms in the bracket so that when you multiply out, you still get 3 terms. Okay, a couple of ones left. Let's have a look at I. There are 2 terms. Highest common factor between 3 and 6 is 3. I have x squared and x, so x is common because then the second term will run out of x's. And I have a y in both, so y is common. Now I say to myself, what must I multiply 3xy by to get 3x squared y? Well, the 3 is fine. The x squared, I'm going to need another x, and the y I've already got, so that's fine. Then what must I multiply 3xy by to get minus 6? That'll have to be minus 2. xy, oh, it's just xy, so I don't need any more letters. And there's my factorizing. Okay, last 2. let's have a look. Here there's two terms. Highest common factor between 5 and 25 is 5. Highest common factor between x and x squared, well, it's only one x, and then the first term will have run out. And then y and y squared, well, there's only y, because then the first term would have run out. And there's my bracket. So I've taken out my highest common factor. What must I multiply 5xy by to get 5xy back? Well, if I just want to get myself back, the only thing I could possibly be multiplying by is 1. And I cannot leave that out, otherwise I won't get it back. 5xy times, well, it's going to have to be positive 5 to get the 25. X needs to become x squared, so that'll need an x, and y needs to become y squared, so I'll need a y. Right, last one to try together. Okay, I've got a squared. Now this looks weird because there's a squared plus a and then a bracket, so that's a little bit weird. So what I might want to do, and I don't always want to do this, so in the next lesson we're going to see when I don't want to multiply out, but because this looks a little weird, why don't I quickly multiply out and get this into 3 terms? And actually then look, I have like terms. So a squared plus a squared is 2a squared plus 3ab. Now, that was simplifying. This question said factorize, but now it looks as simple as it can be, and now I can factorize it. So now there's 2 terms, and my highest common factor is, well, between 2 and 3 there's nothing. So my highest common factor is a, and I said to myself, what must I multiply a by to get 2a squared back? So that's 2a. And what must I multiply a by to get 3ab back? So definitely a 3 and a b. So this was a very weird one, very, very strange question, because initially we had to actually do some simplifying to make it look a little bit prettier and then factorize. Now that's not always how we're going to do it. In the next lesson we're going to do something where there's a bracket and we choose not to multiply out, but we'll leave that for then. Right, now that was quite a few examples. Highest common factor is hugely common and we use it all the time. So in order to make sure that you know how to do it, our classwork is exercise 18.3 on page 238, the first 2 columns. I will also post a PDF of the memo. Please go through it fine-tooth comb. If you've made a mistake, look where your mistake was. Write yourself a note. And if you look at the memo and you think I've made a mistake or you still don't understand what the memo says, please just send me a message, because factorizing is something we really, really want to master. Okay, well done. Keep going.